Utilizing 3D scanners for your project. High-definition laser scanners are rapidly gaining acceptance as one of the best ways to conduct measuring and recording tasks for many of today's projects. Laser scanners collect millions of measured points in a matter of minutes and display these points as a virtual model, comparable to a photograph. Because scanners collect measurements from a distance, they can provide for a safer work environment, as the techs do not need to impede the movement of people and machinery around the site or put themselves in other dangerous situations. The data from the scan can even be manipulated to remove temporary obstructions from the database, providing a cleaner set of data for our clients. The high volume of measurements and the modeling and processing capabilities of the scan software allow us to provide many different deliverables for your project, including measurements. Many types of measurements which are made directly from the point clouds can be annotated in the scans or exported into CAD for markup drawings. These include several types of distance, area, and volume measurements. Point-to-point measurements can provide accurate distances between any 2 points. Caliper measurements can provide direct vertical distances or perpendicular measurements between points and surfaces for clearances and fits. Even area and volume measurements can be extracted from the point cloud, providing accurate quantities and in-depth cut-and-fill analysis. Monitoring. Many types of monitoring tasks can be performed efficiently with high-definition laser scanners. Due to the volume of data collected and the visualization capabilities of the scan software, complete sets of data can be compared to one another and displayed to show every variance in the surfaces of point clouds collected at different times. 3D models can even be generated of the original design and compared to the point cloud to see how much the as-built conditions vary from the original plan. Scanners also collect conventional monitoring data more efficiently. Because the scanner collects data in every direction at once, more targets can be observed in a shorter period of time. Since the technicians don't need to manually sight targets, points that were difficult to locate, like those overhead which require sighting a steep vertical angle, can be observed more easily and precisely. Photorealistic texture maps. Photographs collected at the time and location of the scans can be used to generate a photorealistic texture map for the point cloud, providing a more detailed and easily recognizable image of the site. This is helpful in relating the point cloud to the physical site and provides a visual aid for processing the scan data. Color-coded elevation maps. The point clouds can be displayed in many ways that allow for in-depth visual analysis that are not feasible with other methods. One example is a color-coded deviation or elevation map. These maps can display variations in the surface elevations over the entire target area down to fractions of an inch, allowing for quick identification of trouble areas like puddles and depressions, or analysis of the drainage over the entire surface. 3D models. Many geometric shapes can be modeled with great levels of accuracy for things like cylinders from tunnel sections and shafts. These models can aid in determining center lines or even to compare the as-built conditions of the site back to the original design. Piping sections, including some complex components like flanges, reducers, and valves, can be modeled within the scan software for accurate as-built data collection. Any of these models generated in the scan software can be exported for use in CAD or other design programs, allowing for easy integration into the existing project databases. Alignments and cross-sections. Horizontal and vertical alignments can be either created within the point cloud or imported from an external source. The alignments are then used to generate cross-sections and profiles or to relate scan data to the station and offset information in the site plans. These alignments and sections can be imported and exported directly to and from CAD to help create and harvest information relating to surface elevations and to reduce the amount of data transferred. As you've seen, 3D laser scanners can provide information that previously was unattainable or inherently inefficient by other established methods. The quality of this data and the efficiencies of the workflows can make scanning an extremely viable and economical option for many types of projects in today's world. With the inflow of 3D technologies in the design and construction professions, high-definition laser scanners are rapidly becoming the best tool for measurement and recording tasks on many job sites. Here at White Shield, we have adopted the latest in scanning technologies and software to perform virtually any measurement and modeling task for your project.